So then we move on to mark and recapture. Mark and recapture is used because often plot sampling techniques are hard to do sometimes because animals violate the rules. So they move, they're difficult to observe. So mark and recapture would be more appropriate in these situations. Mark and recapture relies on capturing individuals in an initial sample, marking them, and then sampling the population again and counting the number of individuals recaptured. So whenever you're capturing individuals, mammals, you can use live traps, snares, tranquilizing guns. Birds, you can use mist nets, cannon nets, and baited boxes. Reptiles and amphibians, you can use covered boards, baited traps, and hand collection. Fish, you can use nets, monitoring ladder dams, and electroshocking. Insects, you can use live traps, hand collection, vacuum collection, and baited traps. And then when it comes to marking, for mammals, you could do neck collars, toe clippings, radio transmitters, horn painting, ear notching, birds, leg bands. You get the idea. You would mark them and then you release them, and then you'd capture them all again and count the number of individuals that's already marked in your sample. So the Peterson method of marker capture is the most simple marker capture method. It involves a 3-step marker capture process and provides an intuitive, simple sample and often very accurate estimate of population size. So the basic process is as follows. 1. Collect individuals within a study area. 2. Mark all individuals the same way, then release them back into the study area where they're mixed into a general population. And 3. Collect individuals in the study area at a later time. So this is the equation you would use to determine the total population. M1 is the original number sampled and marked individuals at time 1. N is the total population size. R is the recaptured individuals. And M is the number of individuals sampling at time 2. So if you rework this equation, the bottom equation is where you would get in the total number of the population. Here is an example. If you wish to do this one, please pause and I will go over the answers in a second. So, how good is the estimate? As always, the estimated value of the population size is of little use unless we have an estimate of its reliability. Statistics have diverged for a long time. They're approximate of 95% confidence interval for Pearson method, which is given by that equation on the side. That's how you would calculate your confidence interval for this setup. So from the last example, M1 was 8, M2 was 8, R was 2, and N was 32, which N is the calculated value of the total population, while the actual value, if you had counted the number of rats, was 25. The confidence interval was 19.20, which means that the population was either 12.796 or 51.204. Is this a very good estimate? It's really wide. There's a very big span. The N wasn't an actual value, but it's a way quicker method than either of the two previous ones. So the assumptions for the marker capture: 1, the population is large. 2, the population size remains constant during the study period, so there's no immigration, no births, deaths between samples. 3, the probability of capturing a marked animal is the same of capturing any member of the population. And then 4, marks are not lost between samples and do not affect survival of the organism.